I'll be presenting this paper titled Dzongkha Handwritten Digit Recognition Using Machine Learning Techniques, with paper title paper ID 8524, communicated by Pratyay Kumar Adhikari, Pankaj Jadure, Pradipta Saha, Tamo, Partha Pakre. I, Pratyay Kumar Adhikari, from Computer Science of Engineering Department, NIT Silchar, will be presenting the overview of this paper. So in this paper, first I will discuss about the introduction of the terms that we all should know. Then I will talk about some related works, and then after that I will the data set we have collected, and using that we have applied the algorithms that I will discuss. Then we will be discussing the results of the attempts, and I will be conclude this presentation with the contribution and how we can take this work further. So I would like to introduce the optical character recognition, a common application that automatically classifies image which can be used to detect the various type of characters, either handwritten or printed. If the characters are handwritten, then we may face as difficulty due to the non-uniformity of the handwritten script, as we have evidenced by the variety of the styles found in human handwriting. And finally, the Dzongkha, the national language of Bhutan, which is spoken by the majority of Bhutanese, over 500,000 of people. So there are many opportunities to examine the research and the lack of Dzongkha parallel corpus and dataset needed to develop for image processing applications like OCR we have developed. So our contributions are the image data which we assemble from a total of total of 100 people of Bhutan, of 10 different classes, that was the disease range from 0 to 9. Then the pre-processing has been performed on the generated dataset. After that, the recognition of Dzongkha handwritten disease was done using some machine learning approaches. Finally, a comparative analysis was conducted to evaluate the performance of the machine learning approaches for recognizing Dzongkha handwritten numbers. So there are several works in this domain, such as Savita et al. They designed a hybrid model where CNN performed the feature extraction and SVM aimed for the prediction. This hybrid model has been tested on recognition of handwritten digits. To make it better, they proposed, and on another paper they have proposed another. They have explored several CNN parameters such as the numbers of layers, kernel size, padding durations, straight size, and in order to design an improved CNN-based handwritten digit recognition. Pawan et al. They provided a script invariant handwritten digit recognition system that can distinguish numbers written in 5 major Indian scripts, like there are Bengali, Bhutanese, this language are there. And Peter et al. Used to they made one unsupervised learning strategy, and they achieved 95% accuracy on the MNIST corpus, which is better, performed better than SNN implementations without supervision. Okay, so the dataset we have collected, which is total 1,000 images of for our research. We have 100 sets of numerals because they each have 10 characters, so it will be 1,000. So we utilize the pen and paper tablet to collect the data from the users, from the those who speak Bhutanese, in Google Jamboard. After that, we have saved that PDF, and we have split it as the PNGs, and separated that images based on the IDs we have 0 to 9. And here is the sample image. You can see that a set of disease that we have collected. So I've split it into training and testing, and after this I will talk about the processing, the methodology you have applied for the. So to pre-process that thing, we have first we have converted the colored image into a grayscale image. Then we have applied the Gaussian blur filter to remove the noises from the image. Then converted to a binary image, like a black and white image, and then applied the threshold to get the connected parts of the image. So we don't need the extra parts, so we just get the connected parts of that image. Finally, the resolution was set to 64 into 64, and then map the images with the corresponding IDs in an array, which was labeled before. We have labeled that, and then we splitted the data set into 65% and 35% for testing. So the approaches we have applied applied in this work the most popular and efficient machine learning algorithms. One of them is SVM, which is a supervised machine learning algorithm for classifying, for regression task, and for feature extraction. We have applied two of the kernels in this module. One is linear, and another one which is which we use to tries to find the optimal hyperplane, which is the maximum distance between the hyperplane and the support vectors. In the sigmoid kernel, which is used as a substitute of neural network, mapping the input given between 0 and 1, so that it can be splitted by a direct straight line. After this, we have applied the KNN algorithm, which is a classification method that uses the feature spaces closest, the closest one from the training examples. The training of this method only requires the feature vectors of levels of the training images. The unlabeled query point is simply given the level of its k closest neighbor during the classification process. Objects are typically classified by majority vote based on the levels of their k closest neighbors. Like if the k it's between 1 and n. So if however when k is equals to 1, the model will overfit. If the k is equals to n, so it will underfit. Another approach we have tried is decision trees, which divides the dataset into smaller call subsets, and a correlated decision tree is constructed cumulatively. As a result, the tree decision nodes is formed, but decision trees are fundamentally unreliable and perform best when the input data is large. In our case, which is not, that wasn't enough, so it didn't perform well. So this is the testing part we have done. We have considered the 35% data, 350 images to be exact, for testing, and we have extracted the hop features from these images like before. Then it gave us the output, which is classified in English numbers that we can see in the right side, and on top of it is like a level. And to evaluate the parameters, we have used a F1 score, precision and recall, which will be discussed in the next section. I will discuss that. And here we can see the F score of the applied approaches, where you can see linear SVM gave us the best score with 98% accuracy. With the sigmoid kernel, we have achieved the same, the 98% accuracy. The KNN gave us 96% accuracy, and as our dataset was low, previously I have told that the decision tree didn't perform that well, so we get 79% accuracy in that. Now I'd like to conclude with the contribution of our paper. In the study, we have looked into the potential of machine learning methods to identify and categorize the handwritten Dzongkha numerals. The main reason of doing this work is the lack of Dzongkha handwritten disease dataset, which we have collected manually and compiled a dataset for this study. The recognition and classification of the Dzongkha handwritten disease were then performed using a variety of machine learning algorithms, in which the support vector machine classification algorithm achieved the notable results of the comparison to others. In future, we'll conduct feature extraction and classification of Dzongkha handwritten disease using convolution neural network architecture, and collect more information about the Dzongkha handwritten disease will be gathered from both native and non-native Bhutanese citizens, regardless of their age, gender, education background, whatever it is. And finally, I would like to thank the Center for Natural Language Processing, CNLP, and Artificial Intelligence Lab, Department of CSE, NIT Shilchar, for providing the requisite support and infrastructure to execute this work. These are the references I have used to come up with the presentation, and thank you. Any questions or suggestions will be welcomed.
Okay. So how have you collected the data?
We have collected this data set, we have used on pen tablet, and from the individuals, 100 individuals, we have collected this data set. They have written the individually in one pages, they have written these things, and we have collected the data from that.
There's no repository which has got this type of a data set?
Yes, we have collected manually, we're the first ones. We have collected this data from the Bhutanese people.
Okay.
And
so you mean to say there is very less data set available?
Yes, in this domain, in this Dzongkha language.
Have you compared your work with the existing literature?
There is no existing literature for this dataset, but we have achieved 98% accuracy for this dataset, and the outputs you can see, these are almost accurate. Whatever we are getting, we are giving input and getting outputs.
You can do one thing, compare it with the some other not on this data set, but there must be some other handwritten characters or other data, something you can find that you can compare, that will make your work more
Sure,
like
sure.
solid.
Okay, ma'am.
Ma'am, the
Thanks
thing
for
is
the
that there
suggestion.
is no work has been done for the Dzongkha
For this,
handwritten data set.
yes.
So this is the first work which is performed for the Dzongkha handwritten data set, and this is the first data set for Dzongkha handwritten. So that's why we have not compared our approach with the some existing approaches.
Okay. Okay, fine. Thank you.
Thank you, ma'am.
Hello, Dr. Ankit Kumar.